Okay, so let's go ahead and get right into it again. The equipment side of Section 609, and again, we're going to talk about 1234yf service. We did have a webinar earlier this year on Section 609, but this is going to take a little bit of a different side of it. It's a topic that continues to evolve rapidly. There's new things happening literally on a daily basis. And one of the things that I just want to say real quickly is that really Section 609 is a two-part equation. And what I mean by that is ASE came out with its latest version of its 609 program back in February of this year. And we, by EPA requirement, had to update a lot of the content to cover 1234 refrigerant, CO2 refrigerant, 152 refrigerant, discussion of some of the standards related to equipment, and so on and so forth, and address relevant SAE standards. And our booklet does meet the SAE J2845 standard for technician training for the containment of refrigerants and so on and so forth. And the biggest part about all of that, or what it means to you, is if you took this program back in the early days, and since it's been law since January 1 of 1992, this new program is not anything like that. I mean, it's more intensive, it has a lot more content in it, and you need to spend more time taking it. So you need to take it pretty seriously with this more enhanced content. I just wanted to say that. So, I kind of think of sometimes the Section 609, the technician training and certification side of it, like ours is the software side. Then you got the hardware side, which is the equipment related to it. And it's those two things together that help you meet the 609 requirements according to the federal EPA. And with that, I am now going to switch gears and going to turn this thing over to Peter Cole from Neutronics. And bear with us just a second here as we change. Peter's in a different site from us. Take it away, Peter.
I'm here. Okay. Can you hear me? Dave, can you hear me?
I can hear you. Let's get a little bit of feedback from our audience. Just type in your questions pane.
Everybody good? Everybody can see the presentation? Because I have my questions pane turned off. I'm sure Dave and the gang are going to yell at me when they have something that they want to ask me, but for the moment I'm not looking at my questions pane. I am Peter Call, Vice President of Neutronics Incorporated, actually specifically the Neutronics Refrigerant Analysis Division, and this is about my favorite photo of all time. This is actually my car. It does have the 1234yf license plate. I got that because I have an associate who is the primary 1234yf person for DuPont, who happens to live in the same state that I do, and I wanted to get it before she did, so that's why you see it there. A couple things about me is I am Vice Chairman of the SAE Interior Climate Control Service Committee. We are the folks who make the decisions about what your equipment's going to look like, what your tools are going to look like, and what your service procedures are going to look like, including SAE J2845, the backbone of the new 609 requirements. I'm a consultant to the United Nations and customs departments around the world on refrigerant analysis, refrigerant counterfeiting, and refrigerant contamination. In my past life or future life, I would love to be a Formula One driver. I know that's never going to happen, but I still would love to do that. And since 2007, I've been actively working on 1234yf, and for a little longer than that with the SAE team working on air conditioning of all sorts. So here's what we're going to talk about today. We'll talk about 134A service equipment standards. What are the numbers? What do they mean? And essentially what's different from what we did in the past, way back when. These standards have been out for quite a while, and they laid the basis for our 1234yf standards. We're going to talk about why we're switching refrigerants. What is 1234yf? Why are we even here? And talk about how similar it is to 134A. You might have heard it's a little flammable. We'll talk a little bit about that. We'll talk about the equipment that you need to service 1234yf systems and how that differs or is similar to 134A machines. Some of the new features that are involved and why these new features were put in, what you can expect to see in not only new 1234A machines, but in the future 1234yf machines. Talk a little bit about the AC system changes, things like IHX or internal heat exchangers, and a couple of other things that are being put in systems now to improve efficiency and make the systems run a little better, last a little longer, and so forth. Some changes in evaporators, some changes in lubricants. Are we going to retrofit again? We know that was a huge topic with 12 to 134A. Are we going to be going 134A to 1234yf? We'll talk a little bit about what 1234yf looks like in its packaging. Is it a 30-pound cylinder? What kind of labeling do we expect? And I'll touch a little bit on product distribution, but only a little bit, because you're going to be able to get it everywhere, but we'll give you an idea of what you're looking at when you go to service YF systems. So let's start with 134A service equipment standards. SAE J2788 is the standard for recovery, recycling, recharge machines. The most recent version was published in January of 2013, and the big difference between the 2788 machine and the 2210 machine, or an older style machine, was the new machines had to recover 95% of the refrigerant from a 2005 to 09 Chevy Suburban in 30 minutes or less. It's roughly 3 pounds of refrigerant. These machines allow automatic oil injection. You'll hear later that the YF machines don't do that. SAE Service Committee is not a huge fan of automatic oil injection, especially because of the hybrids and the fact that PAG oil that's often used in these automatic oil injection systems is hydroscopic, so it's going to absorb moisture. When PAG oil absorbs moisture, it creates acid and damages the oil. That happens when you have an unsealed container, and it's not unusual for a container attached to an AC service machine to not have a great seal. And the second problem is you have different weights of PAG oil. So when I have a PAG 100 on the machine and the vehicle calls for a 150, we found that it's not too often that someone's actually changing that bottle of oil to the correct oil, although some machines will accommodate multiple bottles of oil. We just found that automatic oil injection was getting to be a little bit problematic, so we've actually eliminated that in some future standards. We have to consider high voltage vehicles, or hybrid vehicles, when we service 134A systems and subsequently 1234yf systems, and make accommodations that we don't mix the oils. So 2788 came out with a variation called 2788H after we realized that we'd really screwed up and not included it in the original 2788. And 2788H, which is now incorporated into 2788, talks about hybrid vehicles and what warnings and precautions need to be taken to service hybrid vehicles that don't have PAG oil in them. 2788 also mandates that filters on the machine be changed at a predetermined interval, and the machine essentially will require you to enter a serial number of a filter, so it will unlock the machine and allow the machine to be used again if you get to the expiration time of filters. Finally, the last big change was it required automatic air purge. Purging air from the refrigerant was an important thing. Originally, there were some patents involved in that, where certain companies had patents on the process of automatically purging air. As we did 2788, those patents had to be released, what's called a FRAND, fair and reasonable agreement reached to be able to use the patents owned by someone else for the greater good. And so we now have automatic air purge as a requirement in 2788 vehicles. 2788 machines. So this is a list of SAE J2788 approved machines. And I think the important thing to note, and I think you'll see this at the very end, is this comes from a website called macdb.sae.org. The MAC database was created as part of another SAE standard, J2911, as a place where manufacturers of equipment who have gone to a an approved testing lab that meets all the requirements that a testing lab should have, and have had their product tested and have had their product pass the test, they can then send their data to SAE along with a small check, and your product information will be listed on the SAE website. And you might think, well, why would that be important to me? Well, it's important to you because if you see a machine that's listed as 2788 approved and it's not on this website, then that means that that company may have gone to a lab that's not certified. It may have just decided to put a label on it and never tested it. Inevitably, it'll probably be a lower price machine, and you'll find even at places like SEMA and Apex, there are a ton of vendors, particularly from the Far East, that are offering machines for sale that do not meet the new standards, 2788 or 2843 or any other SAE standard. Yet they may advertise them like that. We just found one in Italy advertised as 2788 compliant and has never seen a test lab, at least not an approved test lab. So you want to make sure that any equipment you purchase, particularly going forward, because not all the old equipment is going to be listed here, but the newer equipment for 1234yf and machines for 134A, that they're listed here on the website. So those are the ones that are approved to the January 2013 version of the SAE 2788 standard. Here's a list of the machines that are approved to the January 2010 version of the standard. And you see that list is even longer. These are machines that there was a minor change to the standard, and these machines have been approved before that, and they're not required to update to the new version. But again, they're listed on the website, and the website's searchable on the left-hand side. You can search for different standard numbers and just click on the search button after you check a box, and it will show all the machines that are listed for that particular type of standard. Again, this is that second one, including machines from Mastercool and Robinair and Ritchie Engineering and all the others.
Hey, Peter, this is Dave. I just want to jump in for a real quick second on the Mac DB there for a second. It's very interesting because you and I were talking this afternoon, and I know the audience isn't privileged to know the nature of this discussion, but we were talking about how EPA maintains a list of approved equipment, and that's usually the formula that we've always recommended to people, that they get 609, certification, and then they get equipment that's on that list. And if you go to that list right now and were to look at it, there's nothing on there at all about any 1234 equipment, and there's just a slight or small paragraph that mentions, coming over here with, mentioning under 2911. So for shop owners and technicians, it's really a confusing period right now. And I know you're saying from this point forward to go here, but it's just a little unfortunate that on the EPA list, there's really nothing there.
It is. And what we found is that the EPA is running 1 to 2 years behind where they should be. If you take a look at the EPA list for approved recycling companies, and you jump on the phone and you call a bunch of them, you'll find half of them are a private residence now, because that company went out of business a number of years ago. Half of them, the numbers disconnected. They really, really have fallen behind, unfortunately, with some of their updating of these things. Trying to catch up, putting out a whole bunch of rules. You may have seen some of them concerning other refrigerants in the commercial HVAC sector. But this was created so that everyone has a resource to go to look at what the SAE confirms are approved equipment per the standard, whether it's 2843, 2788, or any other standard. When we get to 2791, you'll see an example of some equipment that has minimal listing, and it has minimal listing because most of that product was approved before the implementation of this website. So when we get to leak detectors, 2791 is the standard we're looking at there. That's 134A leak detectors. Most recent version, again from January of 2013, requires 3 settings: 4, 7, and 14 gram per year detection to meet the needs of older and newer vehicles. Quick quick story. There's an engineer at Ford. Yeah, it turns out to be a good friend of mine over the years. We've spent a lot of time together. Who had a brilliant idea. He said, we want to put a keyboard on the electronic leak detector, and we want you to key in the VIN number of that vehicle that you're working on, and it's automatically going to set the leak detector to the correct leak rate setting. Because if I was working on a car from 1982, that vehicle might leak 14 grams per year, not intentionally, but that was the best they could do back then. And if I'm working on a modern car, something from 2012 maybe 4 grams per year is what we're looking at. And all the manufacturers of leak detectors said, wow, that's a fantastic idea. And he said, well, good, let's write that into the standard. And they said, well, we just want to make sure you're okay with paying $14,000 for a leak detector. Because if you're not okay with paying $14,000 for a leak detector, you may want to rethink the idea of having a keyboard on your leak detector to put in a VIN number. So, you know, a lot of thought goes into this, and they decided that they're just going to go with 3 different settings. They also have to list the chemicals that will cause false triggering, and you've probably seen this in a few different articles over the years, but that's been one of the big problems. So there's a master list of chemicals, and the master list includes, you know, Ford grease number 1236 and a whole bunch of other things, motor oil and whatnot. And you don't have, there's certain items that you can't false trigger on. There's certain items that you have to test against, and if you do false trigger, you have to list them. But among the other things that are commonly false triggering on every leak detector we've ever looked at, coffee, they'll all trip on coffee, and they'll all trip on hot sauce. So if you happen to spill coffee somewhere in the engine bay and you bring out your leak detector and you haven't gotten rid of all the coffee, you can guarantee that leak detector is going to go off. One more note for you, they all trigger on windshield washer fluids. So if you don't know this trick, when you go under the hood of the car and you go to look for a leak, first thing you need to do is make sure your leak detector is working. One great way to do it is just pop the cap off of the windshield washer fluid reservoir and run the leak detector over the top of the reservoir. Not inside, don't dunk it, but over the top, and it should trip. If it doesn't trip, then you have a leak detector problem and you're never going to find a leak. Virtually all of the units approved before 2013 are not listed on the MACDB website. And that's because there's a cost associated with it, and there was no requirement for them to be approved from an earlier standard. So when we take a look at that version of the website, you'll only see the Master Cool item that was approved in January of 2015 listed under the 2791 standard. There are no products currently listed under the older version of 2791. So we want to talk a little bit about why we're going to switch to 1234yf, and eventually we're actually going to talk about the 1234yf equipment, and we're going to compare that to the standards for 134A, and we'll see how similar or how different they might be. In 2016, the EPA mandated that corporate fuel efficiency fleet averages need to be 250 grams per mile of carbon dioxide equivalent. Well, that's a big technical term for 35.5 miles per gallon, is what it amounts to. And in order to achieve those numbers, the vehicle manufacturers started putting out all kinds of hybrids and in different kinds of vehicles and turbocharging 4-cylinder engines and whatnot. But one of the things that the EPA looked at was, we're going to give you credits for certain things. So if you have a vehicle that is environmentally friendly, made with a lot of recycled materials, we'll give you a couple of grams per mile credit for doing that. And the use of a low global warming or environmentally friendly refrigerant was one of the things that you could get a credit for. The credit varies a little bit, but the number ranges somewhere between 7 grams per mile and 18 grams per mile of that 250. We have to keep in mind that as gas prices are going down, everybody's real excited. The price of gas is going down, except the car makers. And they're not so excited because they had plans on selling a certain number of, not to pick on anyone, of Toyota Priuses because people were interested in fuel economy. They were only going to sell so many Toyota Tundra pickup trucks. Well, as fuel prices go down, people get a little more excited about being able to afford to put gas in a Tundra pickup truck, and they start selling more pickup trucks. Unfortunately, they're not as fuel efficient as a Prius. So, their data that they were looking at to be able to meet this average of all the vehicles they sell gets skewed a little bit. So we've actually seen an acceleration in the companies starting to use 1234yf as they've recognized gasoline prices are going down. Low GWP refrigerants, leak reduction, improved efficiency are all things that you can get credits for. Some of those they already got credits for in the 134A systems, but things like 1234yf are new. And this is our incentive to meet the greenhouse gas requirements that the government has decided we need to meet. Like them, dislike them, doesn't matter. They're here. They're not going anywhere. And at the end of the day, some of the good things are pickup trucks that used to get 8 or 10 miles a gallon are now getting 17 or 18 miles per gallon. And we probably aren't noticing a whole lot of difference in performance in those vehicles. Maybe a little more cost, but it is doable in some shape or form. The European Union really was the leader here. They created a law in 2006 that said you cannot use a refrigerant beginning January 1st of 2017 that has a global warming potential of greater than 150. And depending on how you count your beans, global warming potential of R-134A is roughly 1,300 to 1,400. It was 1,430, then they reduced it to 1,300 with some new calculations. The global warming potential of 1234yf is less than 1. So January 1st, 2017, you can't use 134A in a new vehicle in Europe. So, of course, the U.S. realized it's a global market economy and decided this is the direction they were going to go and implement the same rule. So 134A at 1300, 1234yf less than 1. Another consideration was 152A. 152A commonly used in keyboard duster. The problem is it's pretty flammable. And there needed some real considerations on what to do with vehicles in order to mitigate that problem. One of the suggestions from one of the engineers in one of our meetings was, well, we're just going to put some solenoids and some vents into the wheel wells so that if you had a collision, a front-end collision, you could vent the refrigerant into the wheel wells and it would get rid of it and you wouldn't have that flammability risk, until someone reminded them that in a collision like that, the guy was probably, or lady, was probably hard on the brakes, and your brakes could be at 1,500 degrees Fahrenheit. You're about to spray a flammable liquid right onto this 1,500 degree Fahrenheit brakes, so that idea wasn't well accepted. We also have an option of R-744, or the carbon dioxide, that's similar or identical to what carbonates our beer today. That may show up in some vehicles. You may have read some articles that said the Germans are going CO2. Well, I can tell you the Germans would like to go CO2. CO2 has some good sides. It's considered environmentally friendly. Some bad sides. Sorry about that, if you heard that. Hang on one moment for me. I'm back. CO2 has a secondary problem where it's very high pressure, and that high pressure causes some service issues. And it also is not very efficient. So you need a lot of CO2 or a big system in order to cool. So they're going to try to put it in some bigger vehicles, some buses. Audi A8, I think they're looking at putting it in. Volkswagen Phaeton, big vehicles that can afford the weight, that can afford the size, and try to use that for their cooling. But we'll have to kind of take a wait and see approach and see if they come up with some new technology to make that more efficient. So we've already talked about this a little bit, but why was YF chosen? Well, among them was it's very similar to 134A. Performance is very similar. The operating characteristics are very similar. Its safety is very similar. Its low global warming potential. Its short atmospheric lifetime. The properties of YF are almost identical, which means servicing of a YF system is virtually identical to a 134A system. If you take a look at the vapor pressure mirrors that of 1234yf. It's almost identical. It's off 3 degrees at 70 degrees Fahrenheit. I think it's about 71 psi, and 134A is going to be 74 psi. So they're almost on top of each other. The thermal stability under extreme use conditions in Mac systems is very, very good. It doesn't break down. It has a high capacity. And there were only minor design changes that were needed. The one drawback is it's mildly flammable. And we'll talk a little bit about what mildly flammable means, but it's mildly flammable. And that's really in order to get that global warming potential down to less than 1. You have to have a fluid that disintegrates in the atmosphere very quickly, has a very short atmospheric lifetime, and 1234yf does just that. So how flammable is it? Well, it's among the lowest flammable products under the hood, frankly about the lowest flammable product under the hood. If we take a look at this chart, you'll see that you have gasoline, diesel fuel, engine oil, transmission fluid, power steering fluid, and then 1234yf. And we could add in there in this area, right after 1234yf or between power steering and YF, you could add antifreeze, you could add windshield washer fluid. Those are all more flammable than 1234yf. So there were some stories out there, some talk about Daimler and their rejection of 1234yf on the principle of flammability. And when you actually take a close look at their test was a simulation. The simulation was unrealistic, and if they had run that same simulation and instead of spraying 1234yf on the turbo exhaust, and they'd sprayed gasoline on there using the exact same setup from redirecting from the fuel rail instead of from a refrigerant line, and there would have been mass panic that all the vehicles were driving around in could catch on fire because, you know, look what can happen when you put gasoline on something that's 700 degrees C of temperature. So should you be concerned about this? Well, as always, everything that service technicians deal with in the shop, you have to be cognizant of toxicity, flammability, other dangers that are associated with them, things like wearing glasses, wearing gloves. But it's very, very hard to ignite 1234yf. And if you did ignite it, the flame path is very, very short, and it does not burn very hot. So it's very unlikely that it's ever going to catch on fire in the work that you're doing. And there are things that you deal with. Every time you fill a car with oil, you're dealing with a more flammable substance than 1234yf. The difference is it's under pressure. Of course, pressure makes it more hazardous, but no more hazardous than 134A from that perspective. There are a couple of minor differences in systems between 1234yf and 134A. The evaporators in a 1234yf system have to meet SAE J2842, and we also have some differences in the service ports. SAE J2842 was created as an evaporator standard because they wanted to make sure that we had a slightly beefier evaporator because we wanted to reduce the risk of having a leak into the passenger compartment of a mildly flammable fluid. So we created that. We'll find 2842 evaporators in some 134A vehicles, very, very recent 134A vehicles, as they begin to think about making them into 1234yf cars at some point in the not too distant future. But older vehicles won't have an evaporator that meets 2842. Service ports are different, but almost the same. They look like 134A ports, they're just a slightly different size. And typical YF systems will contain something we mentioned earlier, an internal heat exchanger, or an IHX. No moving parts. It's part of the low side plumbing assembly in the system, and it improves cooling efficiency. It helps change the state of the refrigerant from liquid to vapor, or from vapor to liquid, liquid to vapor, to give the refrigerant kind of a kickstart in being able to absorb more heat. 1234yf is slightly less efficient than 134A. Therefore, putting an IHX in there was a little more costly for the manufacturers, but it helped boost the performance of 1234yf systems. They're actually using IHXs in some 134A systems because they're able to very slightly reduce the amount of 134A they have in there, and that helps them with their CAFE carbon credit emissions. This is what an IHX looks like. You've got low temperature, low pressure gas goes on into the inside, and then you have high temperature liquid refrigerant on the outside, and it goes in as one, comes out as the other, and it's really just a dual path, just two paths. And you're going to find that located in the low side line of the system. Looks like a small bulge. If you haven't seen one, it's just kind of like a small bulge, almost like not a TXV, Dave, help me. Whatever that other thing is that I can't remember. So it's located in that line, and non-moving device, non-mechanical, shouldn't ever cause any problems. This is what one looks like. Again, you see two paths, one that goes inside, one that goes outside. And been using them in commercial refrigeration for quite a while, household refrigerators, and they will be in almost all of the 1234yf systems. And the word I was looking for was orifice tube. Looks like kind of the bulge you'd have from an orifice tube. This is the service ports for YF, similar to 134A service ports, almost to the point where you really can't tell them apart. Just a minor difference in size. I happen to know that the one that is second from the right is the high side 1234yf port, and you compare that to the one that is third from the right, and you'll notice that they're almost the same. So again, one won't fit on the other, but they connect the exact same way. Among the other differences you'll notice is under the hood of the car, you're going to have a label. That label is the new J639 label, also references 2842, indicating that it has a 2842 compliant evaporator, and 2845, which is that standard that we used to create the new 609 certification testing. Caution symbol, a flammable symbol, a certified personnel symbol, the amount of refrigerant, little snowflake indicating that you can get burned because it can get really cold, 1234yf, type of oil, and potentially a logo for a manufacturer. Not all manufacturers will use this, but the flammable symbol is really the new thing that's there. How about operation? In operation, 1234yf systems are almost identical to 134A. Again, the pressures, temperatures, characteristics are extremely similar to those that you're used to seeing with a 134A system. So if you know how to diagnose a problem with a 134A system, diagnosing a problem with a 1234yf system will be cake. It's almost the same. Yep, you might have an internal heat exchanger now. But other than that, you're not dealing with secondary loop systems. You're dealing with a direct expansion system that works in a very, very similar way to a 134A. Again, here's the PT curves with 134A and 1234yf, and you can see they are virtually identical. Again, 3 degree difference, 3 degree Fahrenheit, 3 PSI difference at 70 degrees Fahrenheit. Will you need different service techniques and procedures, or will those service and repair procedures be the same as working on a 134 R-12? Well, we just mentioned that the procedures are going to be the same, almost identical. No steep learning curve at all for technicians that are already qualified. One big difference is if you got your 609 card or certificate way back when, in 1997, and you go take that test now, that 609 test now, you better study, because we know you've been working on cars for a long time, but the test is a lot different. Back in the old test, I could take a 10-year-old, give them a credit card and an open book, and they should be able to pass the test. Well, that's not the case now. You need to know a little bit more than you did before, and in reality, that's a good thing. How about certification? Well, right now, there is no certification required to purchase 1234yf. Pretty disappointing from our perspective. We didn't think that was a good idea, but their reasoning for this is, look, we're the EPA, the Environmental Protection Agency. If you say that 1234yf is as good for the environment as you claim it is, then why should we restrict the sale? We didn't restrict the sale of 134A. We're not going to restrict the sale of 1234yf. So eventually, you may expect to see small 1-pound cans of 1234yf on the store shelves, just like 134A. Currently, if you service vehicles for compensation, you have to be certified to 609. Currently, there is no new certification for 1234yf or recertification. However, there is a proposal that's been made that says, yes, people should have to recertify because there's been a lot of changes. You recertify to the new 609, which would talk about YF and talk about CO2. There are enough differences that have taken place since 1992 when that first Section 609 came out that it may be a really good idea for older technicians, we know have been working on cars for a long time, to recertify. So there is a proposal there. Currently, everyone is grandfathered. We'll see if that changes or not. Maybe way down the road if it does. But currently, you're getting about as much information today in this webinar compared to what you would see in the new 609 test that you guys should be able to pass the test just from coming to the webinar today. Can't guarantee that. Probably have to go to another one. But there's enough differences, and you're seeing a lot of them now. So what do we need to do to work with 1234yf? Well, of course, we have new service equipment, new service labels on the cars. We showed you that. 2842 evaporators, new fittings. We talked about that. Recycling machines, cylinders, new oils and dyes, new packaging of refrigerant, and, of course, new ASE technician training 609 class. The minimum equipment required to properly service 1234yf vehicles includes a recovery recycling machine certified to the appropriate SAE J2843 standard. And we say that because that standard has evolved a little bit, and there's a couple of different versions now. But an SAE J2843 approved machine is needed. You now mandates that you must test the refrigerant before you recover it. The machine will automatically ask you to connect a refrigerant analyzer to a USB port on the machine, or we'll use an internal refrigerant analyzer to test the refrigerant before it will be allowed to recover the refrigerant. It locks you out. It also requires the use of a 2913 leak detector. 2913 is the leak detector approved, or the standard for leak detectors approved for use with 1234yf. Very similar to 2791 leak detectors, the 3 different leak rates really just took the standard, substituted 1234yf for 134A, and they went and tested them, made some software changes, and created 2913 leak detectors. One of the parts of the process of servicing the vehicle is the machine will ask you to place a certified leak detector on the passenger floor of the vehicle, and check to make sure that under a pressure test that the vehicle is not leaking refrigerant and that the leak detector is not alarming. So that's why they consider that 2913 leak detector to be a required tool. There's a new standard, SAEJ 3030, which was just approved in July of this year, and 3030 is a dual machine. It's a machine that meets both SAEJ 2843 for servicing 1234yf vehicles, as well as SAEJ 2788 for servicing 134A vehicles. Those machines, both the 2843 and the 3030, may have an integrated refrigerant analyzer, or they can use an external analyzer through a USB port. They must meet the requirements for a mildly flammable refrigerant, or what's called an A2L refrigerant, including things like non-arcing, non-sparking switches, cabinet ventilation, where there's a fan inside there that's circulating the air. A certain number of air exchanges per hour are required because they want to make sure there's no buildup of refrigerant inside that cabinet. There's a two-step process now for checking for leaks, and this has been a bit of contention for some machine manufacturers. The first part is a vacuum decay test, where they pull a vacuum, and this, of course, is after you've recovered the refrigerant. Now you're going to do a vacuum decay, and if it identifies that there's a leak that is too large, that it can't pass the vacuum decay test, the machine stops. The problem with that, in the case of some machines, is if the machine stops, it never lets you get to the pressure check. And if you can't get to the pressure check, you can't get refrigerant back in the system. And if I can't get refrigerant back into the system, I can't use an electronic leak detector to find the leak. So we know they're taking a look at that. That's not all machine manufacturers. That's one that I'm aware of, on how they can bypass that. But from SAE's service committee viewpoint, they should be allowed to charge that 10%, even if they fail the vacuum check. You should be able to charge the 10% of refrigerant in. What you wouldn't be allowed to do is you wouldn't be allowed to charge any more than the 10% in until it passed a vacuum test after that. There is a slight pressure change. If you were to mix 1234yf with 134A, you would get about an 8 psi increase on the high side from a pressure standpoint. It does affect the pressure-temperature relationship from a servicing standpoint, but it does not pose a risk to the system. With other refrigerants, if you mixed 12 and 134A, you created an azeotrope, and an azeotrope had a significantly increased pressure, and that could cause some hazard to the technician and or the equipment they were working on. But you don't quite face that with 134A accidentally mixing with 1234yf. Here's some of the 1234yf machines that are 2843 approved. The FX1234 from CPS. There's also soon to come out an FX3030 from CPS. This is a machine from Bosch Robinair, popular with the Chrysler folks. The Cadillac folks have this machine. And here's one from Mala. Mala used to be known as RTI Technologies years ago, located roughly an hour or so from us here in Pennsylvania, but now known as Mala. And this is their Arctic Pro. You can actually see they have a built-in identifier that sits right here on the front of the machine. The Robinair has one that's inside the machine, and the FX series has an identifier inside also. This is what a 2912 refrigerant analyzer would look like. This is an external unit that would have a USB port that could connect to the AC service machine, so it could give the proper signal of purity of refrigerant and allow the machine to continue to recover the refrigerant from the system. And then here's a few different leak detectors. This one is, I believe, the CPS leak detector This one is a Robin air leak detector. This one is from Technitools, popular in a couple of other brand names that they sell this to. But they're all 2913 certified for use with 1234yf. So what's it all cost? That's what everybody wants to know. What's it all cost? Well, prices will be a little higher than those of 134A tools. You can be assured of that. Early adopters pay early adopter prices. So if you want to be the first guy on that block with that brand new computer that just came out yesterday, you're likely to pay full price for it. As more machines have come out, prices have started to come down. And we expect that to continue. We do not expect them to fall below the current prices for 134A machines, but we expect them to get relatively close. And that goes for leak detectors, refrigerant analyzers, AC service machines, and all those tools. So again, we'll back up to the evaporators. They must meet 2842. If you need to replace an evaporator, you cannot use a rebuilt or a 134A evaporator. So even if you're working on a car that the only change was they put new refrigerant in this version compared to last year's version, you can't use last year's version evaporator in this year's version car because it likely won't meet 2842. It must meet 2842. One of the main reasons we won't see reverse retrofits, that you're not going to use 1234yf in a 134A car. So what's that mean concerning 134A? It means 134A is going to be available for a long time to service 134A cars. If you're not aware, while there's not a whole lot of R12 cars left on the road, there is plenty of R12 available. It's readily available. If you have a 609 certification, there's a whole bunch of places, particular reclaimers, that are happy to sell you a 30-pound cylinder of R12 if you want to use that on a classic car project or something that would just be better with R12. And that's been gone for over 20 years now. So we can expect that 20 years from now, you'll still be able to buy 134A to service 134A cars. One of the questions that often comes up is about dyes and oils. Well, oils for 1234yf cars are different than the oils for 134A cars. Not significantly different, but they have a different additive package. Dyes also are usually propelled by oils. Essentially, a dye is nothing more than the coloring of oil, and then you put that oil dye into a system, and it gives you that fluorescent effect throughout the system. So universal dyes and oils are not a great thing to look at right at the moment because we don't have enough experience with universal dyes to know that the compatibility with 1234yf systems is going to be good in a couple of years. There are some specific dyes that have been released and specific oils that have been released for 1234yf, and we recommend that you stick with things that are designed for YF and not a universal product. In general, YF can be used with the same type of oil as 134A, meaning a PAG or a POE, and the same type of dyes, but not the same dye. The additives in the oils or dyes that are designed to work with 134A are not always well suited for 1234yf. In particular, they found that the additive package that was put into 134A PAG oil was not completely compatible with 1234yf as a refrigerant, and that oil might start to prematurely break down if you were to use that. So you want to stick with an ND12 oil for 1234yf if it's a PAG, or an ND11 if it's a POE, as opposed to an ND8 for 134A. A lot of the manufacturers are trying now to go to a single oil, meaning they're not going to have a 46, a 100, and 150 weight oil. They're trying to go across their line with a single weight oil so that you don't have to stock too many different varieties. But you want to make sure you're using an ND12 or an ND11 for 1234yf systems. When you take a look at a cylinder for 1234yf, you're going to find out that it's 10 pounds, 4.5 kilograms. And why are they smaller? Well, they're smaller because regulatory guidance, that's a word that my friends at Chemours choose to use, or DOT requirements or government regulations, don't want a mildly flammable refrigerant in a larger size transported the same way that we would transport 134A. So the option was to make the cylinder smaller. So they chose a 10-pound cylinder. The other reason is the stuff's pretty expensive. And if I'm going to leak out of a cylinder, I want to only leak out 10 pounds, not 30 pounds. And if I'm going to have one walk away into somebody's back pocket, I only want to have a 10-pounder walk away, not a 30-pounder, because the stuff is not cheap. This is what a cylinder would look like. It actually does look like. This is put in there just to highlight the fact that it is a white cylinder with a red band on it at the top. It's 10 pounds, 4.5 kilograms. It has a pressure relief valve instead of a rupture disc, which is a good thing. It means if it gets too hot, pressure gets too high, it relieves pressure until the pressure goes down, as opposed to blowing out all the refrigerant. Packaging uses a CGA 166 valve. Essentially, it's pretty simple. It's a left-hand Acme thread. So it's the same thread as on a 134A tank, except it's a left-hand thread instead of a right-hand thread. White cylinder with a red band, labeling for flammable product, including the diamond on the carton. And EPA has approved 1234yf for use in small cans. You'll also see no internal or the new internal pressure relief device without the rupture disc. Allows you to blow off refrigerant and then reseal. Service training standards, SAEJ 2845, that of course is the basis for 609. Gives some additional training on 1234yf and CO2 or R-744. For containment of refrigerants used in motor vehicle systems. Talks about the unique requirements for each refrigerant, the mild flammability of YF versus 134A, or the higher pressure of CO2 versus 134A. And technicians now get trained to recognize the type of refrigerant being used, how it needs to be handled, and the proper tools and equipment that are unique to these new refrigerants and any other new refrigerant that may eventually crop itself up. So from a service standpoint, you want to understand the unique differences between YF and 134A, in particular the slight flammability difference, identification of the different fittings and the labels for each refrigerant, along with what kind of tank you're working with. How to use refrigerant identifiers, you're going to need to know how to do that, whether it comes from Neutronics or comes from somebody else. It's mandatory on the 2843 or 3030 machines, so servicing YF systems requires that. You need to know how to use these electronic leak detectors and or fluorescent dyes. Each has a place in the industry. Understand good servicing practice, including proper recovery, recycling, and recharge, as well as the safety and environmental aspects, vehicle recommendations from the manufacturer that are designed really to promote safety for the technician, minimize the impact to the environment, and provide guidance on the appropriate recovery, recycling, and charging equipment. It's important to note that compared to old 134A systems, new 134A systems and subsequently 1234yf systems use significantly less refrigerant than we used to. And that means that refrigerant charge is critical. Those are another aspect of 2788 machines and 2843 machines is their charge accuracy and their scale accuracy for recovery to make sure you get the correct charge. Because overcharging a vehicle will make it inefficient and make that system not work well. And we need to be much more precise than we used to be as these systems have gotten smaller. Finally, technicians have to have a good understanding of the safety requirements that are defined in J639. Now, 639 is a really, really big document, but the idea is that you're working with a high-pressure gas, that that it's a fluid that can burn you if you touch it, and other things related to an air conditioning system that are really there to design to promote safety for you and your coworkers, your shop, and potentially your customers. So who's using 1234yf right now? Well, 1234yf is being used in over 10 models, and that number is continuing to grow. 2015 Jeep, most other Chrysler, Dodge, Jeep, Fiat products have it. Cadillac XTS uses it. And here's a whole list of other vehicles. One note here, a Honda Pilot has it. And soon, another U.S. manufacturer will have it in 2016, another Japanese manufacturer, another Korean manufacturer will have it in 2016. So that list is going to grow and grow rapidly. Whether you see them in the near future or not will really depend on what your customer base looks like and whether you do body shop work or not, how long before the warranties are up, but it's coming, and they're all going to have it eventually. We predict 90% by 2018 of the vehicles being sold here in the U.S. will have 1234yf. So are they required to switch to YF? No, no one is required to switch to YF until 2021. And even then, you're not required to switch to YF. You're required to switch to a refrigerant that meets the EPA's requirements for global warming potential, which should be set, we believe is going to be set at 150, but it won't be 134A. What's it cost? Well, it's substantially more expensive than 134A. This is actually inaccurate because the current list price from a Chrysler dealer is around $1,600. You can expect to pay from a dealer, about $125 a pound. That's $1,250 for a 10-pound cylinder. Now you know why it's not a 30-pound cylinder, because who wants a $4,000 cylinder of gas sitting around? The cost will come down over time. Some of the aftermarket players, CarQuest and so forth, do offer better pricing, but the lowest price I've seen is somewhere in that vicinity of just under $1,000 for a 10-pound cylinder. So is this the end of 134A? Well, as I said, 134A is going to be around for a long time. We've got another 20-plus years of servicing 134A systems. There's no plans to get rid of 134A. We're going to continue to manufacture it for the time being. We're going to continue to use it for quite a while. We're going to service with it really till those vehicles are gone. As I said, we're still servicing our 12 vehicles. And 2021 is the date that has been put into law now. There's an exception or two to 2025 for some special cases, but you won't see any of those. And we have do-it-yourself use of 1234yf and continuing do-it-yourself use of 134A. I'm not a huge fan of that, to be sure, but it is what it is, and that's the way they've ruled. So that's the end of the presentation. I'm actually going to open a separate window here. And Dave, we have questions popped up there. I'm on a different machine than I was earlier.
We do have some questions. And Peter, I think what I'm going to do is I'm just going to go read up from. We kept pace with some of them. Some of them were pretty standard stuff, as far as being certified in 609 and some of the other things. But we do have a couple of equipment questions and a few other things here.
Okay.
I got one question here about sharing this with your students. Absolutely, you can share this presentation with your students. I mentioned in the questions pane to everybody, I hope everybody saw the message, that please take a moment and look in the handouts part of the user interface on your screen, and you see that there's 3 different documents in there, one of them being this presentation, another one being a Section 609 guidance document from the US EPA, and then another one being a resources document that has, some websites and such of where to go to get information. We'll show that screen in a minute. Here, we always have people ask us, could you give me those links? And we prepared a resource document for it. A lot of questions about retrofitting back and forth from 1234 to 134, 134 to 1234. I told people you can't do it in either case. It's just not allowed for, different reasons. And in fact, one of the reasons that you can't put 134 in a 1234 car it gets into a couple of different things, but it actually would be constitute emissions tampering by federal law because that vehicle was certified when it had
That's right.
1234 in it.
Yeah, that's right. When that vehicle went through as part of its CAFE testing to determine its grams per mile of emissions, and any credits that were provided to that vehicle, if it had 1234yf in it, you would lose those credits if you were to put 134a in it, which it then makes really the equivalent of pulling a catalytic converter off of a car, and you're going to end up with more emissions. So it's illegal. Now, everyone will ask me, yeah, but everybody tells me you can do it. Well, you could do it. You could. I'm not going to tell you that you can't. You could not physically put 134A in there, and I'm not going to tell you that it wouldn't blow cold. I don't know what's going to happen in the long term. I can tell you that it's illegal, and I can tell you the next guy that services that car, because you did not change the fittings on there, because there is no retrofitting, it still has 1234yf fittings. The next guy who services it and does it properly and connects his AC service machine to it is going to find out that the wrong refrigerant was in it, because his identifier is going to say, nope, wrong refrigerant, and it's going to reject it. And one of the things that the identifiers do is they don't tell you it's 100% 134A. They tell you something else. They tell you that it's not pure 1234yf. We know it's 100% 134A, but it just needs to be taken care of with a special machine, a 2851 machine, to recover contaminated refrigerant. So it's not a good idea. You're not really going to see any performance increase, and it's only going to cause trouble down the road.
Let's see, Peter, here's another good question. I think how much somebody's using the term Freon, and I know that's a collective word for refrigerant sometime, but how much refrigerant basically do these newer systems use on average? And of course, it says how much should you charge? Well, you're going to have to charge, in addition to what your cost is in order to make money on it. But one of the comments that I added in the questions pane before was that this is a new world now. We're not in a topping off world anymore. I mean, the methodology of charging for refrigerants is different than it was in times past. But I'll go ahead and let you comment on that.
Well, yeah, that's a really good point, is that we are in a recovery and recharge world because we need to make sure we get the right amount in there. Let's tackle the amount of refrigerant in the systems. You're going to see refrigerant systems at 10 ounces or less in some very small vehicles, and you're going to see bigger vehicles still running 2 to 3 pounds of refrigerant. I believe I'd have to actually go out and look, but I think I'm running 13.5 pounds of 13.5 ounces. I'm sorry, 13.5 ounces of 1234yf in my vehicle. So as you've seen 134A systems get smaller, these systems are going to have a similar amount of refrigerant to current modern 134A vehicles produced in the past, say, 3 years. How much should you charge? Well, let's not talk about the amount of refrigerant to charge. Let's talk for just a second about the cost. Because if you're used to buying 134A for $3 or $4 a pound, which is right about the number, $100 for a 30-pound cylinder, maybe a little higher, maybe a little lower, and charging customers $15 or $20 or whatever the number is, $15 or $20 a pound, but you're only putting a pound in or 2 pounds in. So the customer's paying $20, $30, $40 for refrigerant. Take those same margins. So mark up your cost of 1234yf. Let's say it's $100 a pound cost, and mark it up 3 times. Now you're going to charge the customer $300 for the refrigerant. Well, that's kind of insane. You need to look at it not from a percentage margin standpoint. You need to look at it in raw dollars. If that was a 134A car, and you had a cost of the refrigerant of $4, and you charged them $20, you just made $16. Well, if I'm a YF system and I have a cost of $100 and I charge them $175, I just made $75. Now, from a margin standpoint, it starts to eat into the math, but the reality is trying to charge $300 for the refrigerant is going to be problematic. So you're going to have to look at real dollars, not percentage. Dave, what else we got? Dave, you with me? I hear something.
Yeah, I'm sorry, Peter. Here's one. Somebody has a question about their machine, and it says
Okay.
our new machine has a big fault. If you charge a system and a leak appears, the time this machine takes to clear and purge allows much of the refrigerant to escape. Is this going to be addressed?
Well, I don't think that's a standard issue. I think that's a machine issue with the manufacturer. So you'd need to really talk to the manufacturer of that machine. Obviously, as a committee member, I'm in touch with all those folks. So if somebody gets a message to me privately, I could probably help them get in touch with the right people. But I don't believe that's a standard issue. I think that is a machine issue. Although the machines do take a little bit longer between the identifier test, the required vacuum decay test, and the required pressure test. It is going to take a little longer to service a vehicle.
And here's one about what is the average price of a good leak detector and what are good ones to stay away from? And I know you can't make a brand recommendation, but is there any general recommendations you can make there?
Well, I'll talk to you about the different technologies. There's really two basic technologies. There's infrared. Infrared tends to be a little bit more expensive. As a general rule, infrared is offered by companies like Infocon, makes an infrared leak detector, and Robinair has an infrared leak detector. And then there are heated diode, heated pentode, heated sensor leak detectors. They tend to be a little less expensive. We hear good things and bad things. We hear that Infocon makes a really good. There's a lot of people that like a particular version of an Infocon leak detector. We know a lot of people who like the infrared that Robinair has come out with, and we know a lot of people who like the Technotools version of the tool. I think more than anyone realizes, the tools really perform in a similar way. I think technique has a lot to do with it, especially on the infrared leak detectors, making sure the environment you're working with them, and believe it or not, having a positive attitude that this thing's going to work, and not thinking initially that, well, these never work. So unfortunately, I can't really give you a brand recommendation. I can tell you that newer leak detectors are better than leak detectors used to be. Uh-oh.
And then we had another one. I switched over, Peter.
Yep, I got you.
But one of the other ones we had, and I think it's a little bit of a troubling question. We had actually multiple people ask the same question about what kind of adapters are adapters going to be available so that they can just use the same gauge set. And to my knowledge, that's not allowed.
Well, I can tell you that there are adapters out there now.
Right.
There's a company that came to us a couple years ago and said, hey, this is really cool. Look at this. We got this great adapter. And their intention on the adapter was this adapter is going to be for injecting oil because 1234yf machines do not allow automatic oil injection. So you need manual oil injection. And they said, well, it's because you can use your injector gun now. You can use it on a 134A system with a 134A cartridge, or instead of having a whole new gun, you can just snap this adapter on the end, which has essentially a male nipple that plugs into the 134A coupler and then has a 1234yf coupler on the other side to connect to the vehicle. So we know those are going to be out there. We would not recommend doing that, especially on a gauge set, because one of the things you're going to end up doing is you're going to end up mixing refrigerant, and at some point in time, you're going to fail a refrigerant ID test. And I know that you'll purge them out of the gauges and so forth. What I would look at is a dual gauge, because there are some companies which will provide you with a gauge that will do both and provide you with two different hose sets with that. But to be honest, if you look around, you're going to find those adapters out there. One of the differences in those couplers is one has an M14 thread in the back of it that connects to the hose to the coupler. That's the 134A. And the 1234yf uses an M12 thread. So you can't just buy a coupler and thread it onto a different set of hoses.
Dave?
Oh yeah, go ahead.
Can I interrupt for just a second?
Sure can, Dan, go ahead.
For those of you that are trying to download the documents and handouts from the handouts pane, if you have an issue with being able to save them, please rename them just something else, like AC 609 webinar, something like that, and they will save properly. I noticed that's a little bit of an issue on some of the web browsers. So that's your heads up. Just rename them, save them somewhere on your desktop or wherever, and it should work fine.
While I'm at it, I'm actually, now that you're on your screen, I'm actually on the question screen. So let me tap a couple of these starting. I'm kind of working bottom up. Mixing two refrigerants, will it cause an issue with machine detecting the type of refrigerant? Absolutely, the machine will tell you it's contaminated and will be a problem. The machine won't work, or I should say the machine will stop recovering refrigerant. We're obviously not retrofitting like we did with 12 and 134A. Somebody mentioned some tax breaks for independent shops switching over the newer YF equipment. We are not aware of any tax breaks from a federal level. I'm also not aware of any state level tax breaks other than the typical capital equipment tax benefits that you might get depending on how much money your shop has made in a given year and how much you want to spend on capital equipment. But nothing special for 1234yf. Will a YF leak detector also work on 134A? That's an excellent question. Do I think they will? Refrigerant's refrigerant. I think you will be able to detect 134A leaks with a 1234yf leak detector. What I cannot tell you for sure is whether or not it will detect both refrigerants with an equal precision. If it's a YF leak detector, it may not detect 134A with the level of precision that a 134A leak detector would do.
Hey, Peter, if you wouldn't mind, could you comment? We've got a number of different questions throughout the evening tonight about machines bridging the gap in between, the 1234 and 134 machine, and I know it brings the J3030 standard. Can you talk about that a little bit, please? Sure.
3030, again, was approved very recently. There are currently no machines approved to SAE J3030. I can tell you that right now. However, there's at least one manufacturer who's in testing for approval, and I expect them to be approved. The idea behind a 3030 machine is you buy the machine, and you configure it. By configure it, you push a button and you put the right hoses on it for the refrigerant you want to work on. So let's assume that you are in the market for a new 134A machine, but you're a little hesitant because this new refrigerant's coming out. You may really want to look at a 3030. You would service 29 days out of the month. You'd service 134A cars just like you always have with this new 3030 machine set up as a 134A. And then that day when a 1234YF car comes in, you push a button. Takes anywhere from 5 to 15 minutes. It creates a clearing process in the hoses, and it clears out the entire machine of the old refrigerant. Essentially pulls a huge vacuum on all the components in there to suck all the 134A out of them to allow you to switch tanks and put a 1234YF tank on it and put 1234YF hoses on it. And then that machine, you push a button, tell it, I want to be a 1234YF machine. And now it's a 1234YF machine. Use it for that day or that vehicle, and then switch it back. Again, it takes 5 to 15 minutes to switch it. The big advantage there is that machine, while you're paying for it, is not sitting in the corner doing nothing. From a cost perspective, I did look that up today, and machine was being advertised at a little over $6,000 for a dual 3030 machine. Although I can tell you the certification is not done yet. So that's why a 3030 machine could be an advantage, especially in the transition, and especially if you'd really like to have something updated on 134A, but are afraid to have that dual expense. Eventually, when you see a lot more 1234yf cars, then you might regulate that 3030 machine to be a dedicated YF machine, because you'll have fewer 134A cars around now that more YF are coming in. Or you may buy a dedicated 1234yf machine and leave your 3030 machine as a versatile back and forth. And I will expect before the end of the year you'll see 3030 machines on the market.
Peter, one of the interesting questions that I don't know the answer to, I see it in the questions pane right now, is what do you do if you encounter contaminated refrigerant? What do you do with it?
Okay. In the there are two. I'll give you the official line. We'll start there. If you encounter contaminated 1234yf, you are supposed to use an SAE J2851 recovery machine. It's a recovery only for contaminated 1234yf, to recover that refrigerant into a cylinder and then send it off to an EPA-approved disposal reclaimer. That's the official thing to do. Same thing with 134A, except you would use a different machine. Now, if I know that the refrigerant's not flammable, meaning I know it's mixed R22 and 134A, then I might just use a vacuum pump and put it into a contaminated cylinder. And when I get enough refrigerant in that cylinder, I may send it off and not have to worry about it. The big thing is you want to avoid flammable refrigerants with vacuum pumps because they're electric in nature. You really need to use an air-driven vacuum pump. But essentially, you can't vent it to the air. You have to recover it into a dedicated cylinder, and then at some point in time, you have to send it off to be separated or destroyed. And that's a relatively costly process. Let's assume it's $7 a pound plus shipping to send it off. And also, it's important to know what it was contaminated with, because that can have an impact on how you service the system. Things like R22 can have a negative impact on the seats and seals and O-rings of a system. And if you have a problem with those, you're in for a lot more work than if it was contaminated with, say, propane. Propane's flammable, but it doesn't hurt the seals of the system, the rubber in the system. I see a question here about 134A hybrid systems, PAG oil, not the correct oil, long-term problems. It's really not a case of long-term problems. 1% contamination of the oil between a PAG and a POE in a hybrid system can cause the case of the compressor to become electrified. And that's really the problem, is it could cause the vehicle to shut down, could cause a hazard to the technician, and that's why we want to make sure that we're only using the correct oil there. From a long-term perspective, yeah, you're likely to damage the compressor if you have a PAG instead of a POE.
Peter, looks like we had a question or two about the
Maybe
IHX being a serviceable component. I mean, that's not a routinely replaceable thing. It's just part of the system design. It would be only in a catastrophic situation that replacement be required. Is that right?
Yeah, that's correct. But also, it's serviceable like a hose. If you had to replace a hose, the IHX would be a part of that hose. When a hose could be rubber or could be metal.
Probably not a cheap hose either.
You're not going to replace the IHX itself. Yeah, that's right. You're likely not to replace the IHX itself because it's going to be built into one of the lines there. Somebody mentions molecule size. 134A has a smaller molecule. How does 1234yf compare? They're almost the same. 134A has a smaller molecule than R12. That's why we ended up with barrier hoses, because we were afraid that we would allow the 134A to escape through non-barrier hoses and essentially have leaking hoses. 1234yf, very similar to 134A in that aspect.
What about sealers that come in a system? Can you comment on those just generally? I mean, is there a sealer in there from the factory, and then is there maximum amounts of it?
There is no sealer ever from a factory. Factory supplies refrigerant, oil, and on occasion dye. Some systems have dye from the factory, some do not. There are no sealants in the system. Every vehicle manufacturer that I am aware of is not a fan of sealants. And it's not because they want to go replace components. It's because sealants can do the wrong sealants. I never want to say all, because there may be some out there that do not have issues, but sealants generally are designed to seal holes where there's a whole bunch of small holes in an AC system. Thermal expansion valves, orifice tubes, IHXs now, and they can cause havoc in a system. Also, a lot of sealers react with moisture and air. There's always moisture in a system. And in reality, if you need to put a sealant in a system, that means that system has a problem. And you really are not trying to put a Band-Aid on something that needs surgery. There are some exceptions. If you have a vehicle that is too old to worry about fixing the air conditioning, it's not worth enough to spend whatever the number is, $1,000 on. Would I try sealant? Sure, I would. Because if it fixes my problem, I get cold air. If it doesn't fix my problem, I spent $20. But it's a repair of last resort, if you will. I'm not aware of any sealants for 1234yf, but you can bet that as soon as vehicles start coming out of warranty, they'll be available.
Someone popped the question about what about counterfeit R-1234yf? I mean, when we're looking at the price of where this stuff is at, it's probably a pretty good question.
Yeah, there's no doubt you're going to have counterfeit 1234yf. We see a lot of counterfeit 134A now, and there's no question there'll be counterfeit 1234yf. Anything someone is selling to you at a great price out of the back of a pickup truck is probably not what you want to buy. There's actually a new SAE standard out on the aerospace side that was worked on recently that gives good practice. Essentially, buy from authorized distributors, buy from known sources. One advantage, one of the reasons they required refrigerant analyzers for 1234yf machines before you pull the refrigerant out or in the process of pulling it out, is they were concerned that the price of this refrigerant was very high. People will counterfeit anything where they think there's a profit to be made, and you can bet that there will be 1234yf counterfeits, especially as soon as there are suppliers other than DuPont and Honeywell. Either when the patent runs out, when the patent's thrown out, when agreements are made to allow other people to sell that, that's when you can be sure the counterfeit material will show up. We believe that on your shelf at your local auto supply store for Joe Backyard Mechanic or Mr. Do-It-Yourself, you will find 134A in a can, you will find 1234yf in a can, and there'll be $10 for the 134A, $100 for the YF, and you'll find a can for $50 of 1234yf light, which will be 134A in a can marked 1234yf light. Which might solve somebody's short-term problem, but who knows what kind of long-term problem. And in reality, how often does putting a can of refrigerant in the system actually fix what's wrong with the system? Eventually, that system's going to go, or that vehicle is going to go to a professional, and when he connects his machine to it, and the analyzer says this isn't pure 1234yf, now somebody really has to pay the price. So it's going to be a fun time over the next 5 or 10 years. See a whole bunch of people help me with my orifice tube issue there. I don't know why it just jumped completely out of my mind.
Peter,
Dave,
can you comment on one thing we didn't really talk about it much tonight, but on the not only leak detector meeting the SAE standard, but there's also a technician procedure for how fast they move the probe and the proximity to a suspected leak, that kind of thing.
Yeah, those are generally detailed in the instructions for the leak detector. The standard itself is the test that a leak detector must undergo, and it says something like you have to move. And I'm not staring at the standard, so I'll inevitably get this off by a little bit, but that you have to move it at 3 inches per second, and it has to clear within a certain distance of getting away from the leak and so forth. And that standard is done and then essentially repeated back in the manual to tell you how quickly to move it and what distance from the suspected leak. There's other things too that when you're using a refrigerant leak detector, refrigerant's heavy. Refrigerant's going to go to the ground. So you're much more likely to find it an inch below a leaking line than an inch above a leaking line. Because even at an inch above, it's gone out of the line and then immediately wants to fall to the floor. So there's some really good procedural stuff, and generally it's written in the manuals. And I know you guys are probably like me. The last thing I do is read the manual, especially if I'm setting up something at home, because I don't ever ask for directions either. I'll lose a tank of gas getting lost before I'll ask for direction because I'm a guy. Dave, I'll mention that I was on a call right before this. I was on a call with State of California, and State of California had this real interesting thing where they had a can deposit for small cans. So if you were to buy a small can in the State of California, you had to pay a $10 deposit, and you could get that $10 back when you returned the small can. Even if it was empty, just return the can. Looks like they're throwing that out. There will be no more can deposits in California, and we just find that interesting because we were kind of hoping that same concept might catch on to other parts of the country. But if California is going to get rid of it, then it's unlikely that we'll see any change there. So we can expect to see small cans of refrigerant on the shelf for quite a while. Somebody asks if 1234yf catches fire, how toxic is it? Well, if 1234yf catches fire and 134A catches fire, I'd rather be near the YF than the 134A. The amount of hydrofluoric acid put off by a 134A fire is slightly higher than that put off by a 1234yf fire. It's unlikely that either one will catch fire, and it's likely that if you have a front-end collision and an under-hood fire, that the effect of burning either refrigerant would be not a good thing to have. So it's really not any more toxic than 134A from that standpoint.
Peter, one of the questions here was on 1234 in Europe, and that was such a controversial thing with the whole Daimler situation and all that situation that came up. And we had talked about earlier the Cooling Post article that looks like nearly 500,000 cars in Germany now are using 1234 that are registered there.
Yep.
So that's quite an uptake.
Yeah, and there's 7 million cars expected to be using 1234yf by the end of the year. I'll give you the short version of the whole Daimler thing. Daimler may have had some other motivation. I'm not sure what it was, but I happened to be in Germany giving a speech at Automechanica Germany, and following me was the folks from Honeywell, and then right after them were the VDA, essentially the German car makers, and they closed their presentation with 1234yf is as safe to use in a motor vehicle as 134A, and it was authored by the BMW guy and the Daimler guy and a VDA guy and a guy from Opel. So I come home, that was the 18th of September 2012. I come home the 25th of September. I'm actually at an Army depot doing some field work on R134A and R40, And I get a call and said, did you see the press release? So amazingly, in a week, they went from it's as safe to use as 134A to don't use this. Well, essentially what they did was they took a vehicle, they rerouted the refrigerant line, and put a special nozzle in place to blow the refrigerant in a certain spray pattern on a superheated turbo exhaust to prove that they could catch it on fire if they superheated it. Well, it's all stuff we knew already. What they failed to do was they called it a real-world scenario, but yet there was no damage to the vehicle, meaning no front-end damage. It was almost like the only thing that happened was Thor, God of Thunder, took a javelin and threw it through the hood of the car and clipped a refrigerant line at just the right place to blow a certain spray pattern on the turbocharger. So it was an unrealistic scenario, even to the point where some people said, well, why don't you do the same thing with the fuel line? Take the fuel line, reroute it, put it through that special nozzle, and blow it on the exhaust of the turbocharger and see if it catches on fire. Because if it does catch on fire, then we probably shouldn't use gasoline. So it was really an unrealistic test. It wasn't news to us. Unfortunately, it caused a big uproar there. There's some speculation on their motivation. It was about delivery of product. It was about the price of the product. It was about the limited number of sources for the product. And I don't know that we'll ever know. But January 1st, 2017 is coming up, and we'll find out if they have an alternate solution, if they move everything to CO2, if they ignore the law in Europe. What I can tell you is that Volkswagen will be using 1234yf, BMW is currently using 1234yf, and Daimler is the only holdout at the moment.
All right, well, all good things must come to an end, and this is probably a point where we should bring this webinar to an end. And I want to thank everybody for attending tonight. Peter, I also want to say thank you personally for helping everybody out tonight. I think we got a lot of good feedback in the questions pane about instructors and so on and so forth, learning a lot during the session, as did I. And I want to again personally thank you for being our presenter tonight. And to everyone out there, on behalf of Peter Cole from Neutronics, Dan Baumhart, Don Du, and myself, Dave Kappert, thanks for joining us, and we'll see you at an ASE webinar soon.